You guys, welcome to lesson 3. We're going to talk about atoms and ions. It should be a short lesson. There's a couple things I'm trying to improve on in my videos. I'm an amateur for sure, but I'm trying to get better with each time. One time I'm adding the text. I'm also going to try to speed up things, keep moving forward. So bear with me as I get better, but know that I'm going to try to make it. I really do want to begin with a review of yesterday's content because it ties in today, and today should be a shorter lesson. So let's review which subatomic particles are located in the nucleus. So good review for you. This is, by the way, on page 9 of your note packet. So which subatomic particles are located in the nucleus? Well, it's the protons and the neutrons. Which subatomic particles are located outside the nucleus? The electron, which have a charge of positive or negative. Protons are positive, think P positive, and electrons are negative charged, which have mass. Only protons and neutrons are considered to have mass. Electrons are so negligible. What is the term particles located in the nucleus? We have a special name for them. We call them nucleons. I might use other names and I'll mention those as I go through them. All right. If you know the element symbol, which of the numbers from the previous chart do you automatically know? Well, definitely if you know the symbol, you can look up its atomic number. And that means you know the number of protons because that's the same thing. You know its nuclear charge, which is also the same thing. You probably know the number of electrons if it's a neutral atom, which we'll be talking about today. If you have a nuclear charge, number of protons, and what other numbers do you know? Well, if you know the nuclear charge, you know its atomic number. Nuclear charge doesn't change in elements. If you know it's a neutral atom, you know the number of electrons too. So, and a neutral atom, the number which two subparticles is always the same. Okay, in a neutral atom, the number of protons and electrons are always the same. All right, let's jump now to page 10. This is actually what we're working on today. And as you may have seen, where is that? I want to bring up the main slide here. We're going to differentiate between an anion and a cation. We're going to determine the number of protons, neutrons, and electrons are in a neutral atom and an ion. So let's talk about neutral atoms first. First of all, neutral atoms. Okay, so just like their name suggests, it's an atom. Oh, I should use my text feature. And try to go a little faster than having the buttons. It's an atom with the same number of protons. And what's the thing that balances out protons? And electrons. Electrons and protons balance each other. So it's where P equals E. And I wanted this to be a lowercase p. All right. What's an example? I'll give you an example. Say carbon has an atomic number of 6 and mass number of 12. And you'll notice there's no indicated charge. There's no positive or negative symbol up here. So this is also another way to write a neutral atom. And I know I can't say what's not there. It's hard to see, but there's no charge indicated. You'll notice how that's different on the next ones. Okay, we now have ions. And ions are probably the most important thing in general chemistry for you to understand. Ions are when atoms carry a positive charge or a negative charge. So there's this little substance called an atom, the atomos that we talked about yesterday. And this tiny little particle, we believe, can carry a positive or negative charge or multiples of that based on the number of electrons that it carries. So let's talk about that first. We have a special type of ion called an anion. And you can see ion right on its name. It means it's an atom that has gained something negative. So it has gained an electron. Oh. And I really could put the CS because it could have gained more than one electron. So when the electrons are greater than the number of protons, it creates a negative ion called an anion. And the similar can occur called a cation. It's an atom that has gained or lost something negative to become more positive. So we say an atom that has lost one or more electrons. Okay, so the number of protons exceeds the number of electrons. So if there's more positive things in your life than negative things in your life, you'll be more generally positive and happy. You'll be a positive ion. Well, chemically speaking, maybe not, but that's how chemistry works. If you gain or lose those negative particles, you will gain positive things. So what's happening here? I'll give examples. Let's take fluorine. Fluorine has a mass number of, let's say, 19. It has 9 protons. And let's say it carries a -1 charge. And if we read this in some sort of chemical formula, we have to recognize that the -1 indicates a negative charge that the whole ion carries. Notice I didn't refer to it just as an atom. I refer to it now as an ion. So indicates a -1 charge. Now, it has a magnitude of its negativity of 1. So its magnetivity is the level. So if it's -1, it has a magnitude of 1. Sorry, magnitude. Sorry, just a moment to get some water. The video. All right, sorry about that. I was just finishing up this. It was a magnitude of 1. But it has a negative charge. Okay. It's really 1. Let's look at cations, same idea. Let's look at lithium. Lithium is over here on the periodic table. There we go. Lithium has, you'll see it's, we write its symbol. And let's say I gave it to you. It's mass number's 3, its atomic number's 3, its atomic number's 3, its mass number 7. Let's say it carries a +1 charge, which it often does. And it's this part that is the part that you can read that it's an ion or not, okay? It's not very difficult. The +1 charge indicates, just like we thought, a positive charge with a magnitude of 1. All right, that's all there is to ions, really. Let's look at some questions about them. When a neutral atom gains an electron, it becomes, well, remember we have, let's say, a neutral atom has no charge. An electron comes by and joins up to it. If it has no charge, after the fact, when the electron attacks it or comes to it, it will carry a negative charge, because if it's a 0 charge, plus a -1 charge that will add up to a -1 charge for the new ion form. So it'll be a negative cation and negative. So just remember, anions are negative. So these cannot be positive. You can never have a positive anion. You can never have a negative cation. So then we just have to decide whether it's positive or negative. Like I indicated, it's negative. So it's a negative ion. All right, next one. When a neutral atom loses an electron. So it's a neutral atom. And then an electron. I should, let's say we have an atom of, let's say, oxygen. No, let's do something easier. Fluorine. And I'll show you why I choose fluorine. Because if we look over at fluorine, there's fluorine right there, you'll see it has an oxidation state of -1. So it often likes to carry a negative charge. So fluorine is just sitting there, but then it loses. My bad. I wish I could rewind. Fluorine is not an example. This is one example of like the top one of an electron joining it. So I'm sorry. I was thinking the last example, one example behind. All right, let's go back to our, this is a good example for this one, an electron joining an atom. Let's take a look at lithium. Lithium is fine normally, but it's happy losing an electron. And when it loses an electron, and I'll show you why, because if you look over here, it has a +1 charge. So what it does is it automatically loses. And to stay balanced, you'll notice lithium carries a positive charge once it loses an ion. So what does this atom become? It was a neutral atom, lost an electron, now it's positive. So we know it's going to be A or D. So it can't be A or C. Sorry, it's B or D. It's definitely positive, and then you just have to recognize cation means positive. Okay, what is the charge of magnesium that has lost 2 electrons? Well, we can look over here, and in fact, it does lose 2 electrons. And then I can write a simple formula to explain it. But the key idea here is if you lose something negative, if you lose 2 negative things in your life, you've lost 2 electrons, 2 -1 charges, you're going to be +2. So magnesium will carry a +2 charge. What is the charge of a fluoride? Actually, I gave the example here that has gained an electron. So here's the example here. We have a fluorine atom, and an electron comes over here and attaches itself to fluorine to make it a negative ion. So what is the charge? It's going to be -1. What is the charge for magnesium? +2. I guess that's all I had to write. All right, number 5. When a symbol S-2 represents at what? Well, S represents, if you look over here, you might say, I don't even know what element that is. Well, understood. If you look on the next page over, and you're not sure about the name, even though I gave you these is one of the things that I wanted you to look at. You'll see sulfur right there is S. So try not to ignore those Quizlets. Knowing those element names will be pretty useful. Okay, either way, there's our sulfur. Oh, I need to just move it over a little. Cation formed as a result. So we know it's sulfur. Unfortunately, that's all of our options do too. We know that it's negative. That means we can get rid of all the positive things because it's not a cation, not a cation. It's an anion. And how do we get it to be a negative? Well, to be negative, you've had to gain 2 electrons. So we had to have 2 electrons join up with sulfur atom. And after they join up, sulfur will carry a -2 charge. And so right here, we're going to say anion formed by losing or gaining 2 electrons. If you notice this in this formula, it has gained 2 electrons. So it's option D, if that makes sense. These will be useful because most of your homework is multiple choice. A chemical Fe represents Well, it's positive, so we can get rid of these two options. And then we have to say, how do you gain positive things in your life? By losing negative things or gaining positive things. Oh, electrons are negative, so we know we can't gain them to be more positive, so we must lose electrons. And that's why it's a cation formed from losing 3 electrons. Okay, give a correct symbol for the ion formed when oxygen gains 2 electrons. Gaining electrons make it more negative or positive is the question. Well, we know it's going to be negative, and it's going to be -2 because it gained 2. The symbol for oxygen is just O. So that symbol is fine, or this symbol. Okay, with the charge afterwards. Given the correct chemical symbol for the ion formed when sodium loses an electron. So we have sodium, we need to look that up. It's Na. And if you lose an electron, do you agree that you become positive? So the correct symbol for an ion formed is just Na positive. We don't need to indicate a 1 when it's just a positive 1. All right, I think we're set. That's it for the notes. The homework is just like you'd expect it to be. It's going to be, well, it's page 8 to 10. So if you haven't already turned there, I'm going to look at the homework with you because hopefully the video went shorter than the previous ones. There we go. These are all good practice ones. Man, there's so much good stuff. 8 to 10. So you start here, write the full chemical symbol for the ion with 12 protons and 10 neutrons. So the first thing is we look up element 12, and that will identify our element. So element 12 is magnesium. You'll see element 12. So I'm going to write magnesium here. And to be balanced, it wants 12 electrons. And originally, because it always matches, the atom always matches the number of electrons. But if it went to 10 electrons, that means it lost 2 electrons, which means it has a +2 charge because it lost 2 negative components to it. Hope that makes sense. Okay, what's the element with 74 protons? Well, you take a look at your periodic table, you look for element number 74. Okay, and you say to yourself, well, that's element W. I don't know what element W is. Well, don't forget, turn the page. As long as it's under element 89, you'll be able to find it. It's tungsten. You notice how I think we got the idea. So we write the element symbol. And we say to ourselves, tungsten was supposed to have 74 protons. It was supposed to have 74 electrons. But it lost 6 electrons. That means it must carry a +6 charge. All right. All right, try the rest just like that. Determine the number of P and E for each of these. Very good. Let's try the first one. Copper is +2. So we look up copper. And copper Cu, some of these things you'll just get to know as you use them. Its atomic number is a number of protons, which is 29. The number of neutrons is going to be its mass number, which is 64, minus the number of protons, which is 35, I believe. So 35 neutrons. The number of electrons it should have it should be the same as the number of protons, but it's +2, so it must have lost 2 electrons. So its number of electrons must be 27 electrons to give it an over +2 charge. So make sure you have the numbers 29, 35, and 27. Should I try one more easier one here? Lithium. I know, right? Lithium, number of protons, that's element number 3. So that's easy. Number of neutrons, its mass number is 7. So it must have 4 neutrons. Number of electrons is normally 3, but because it's positive, did it gain, or it must have lost an electron, at least one, to give it a positive 1 charge. So it has 2 electrons. Hope that makes sense. We'll go over that tomorrow. This one is the same idea. You're given the ion, you're given the number of electrons, atomic number, and mass number. And it's all the way to 10. And since 9 and 10 are basically the same, I was just going to do one of them. I don't know if you guys had a preference, but I'll do one I haven't done. Let's do aluminum on page 10. Is an atom or ion. There's a charge, so it's an ion. Number of protons, you just simply look up at aluminum and see it's element 13. So it's 13. Then you take a look at its mass number. Its mass number is 26.98, I believe. Let me double check. Yep. Sorry, I had to take a look at that sucker. So that's 27. So I take 27 mass number minus the protons, which is 13, and I get a total of 14 neutrons. Number of electrons, well, normally it would be 13, but you notice it lost 3 electrons to carry a positive charge, so it has 10 electrons. The mass number is 27. Its nuclear charge is the number of protons. That doesn't change. Nuclear charges and protons don't change. All right. Maybe I should do one more just to help you guys out. I do think these can be a challenge. So if you're good, go for it. But if not, let me just do one more for those who might want it. Atom or ion, you see the positive charge. Oh, let me do a negative one. Oxygen, that'd be a good one. I haven't done a negative one. That's why. All right, oxygen. First of all, it tells us its mass number is an atom or ion. This is definitely an ion. Let me look at the header. Number of protons. Well, the oxygen has no choice. It always has 8 protons. Its atomic number is 8. Now, if its mass number is 15, which they give us this time, I just have to take 15 minus 8, and that's 7. And that's why there's 7 neutrons. Now, the number of electrons should equal the number of protons for a neutral, but we notice here that it has 2 negative charges, a magnitude of 2. That means 2 electrons were added. So I have to add 2 electrons. That gives a total of 10 electrons because it's 2 overcharged. The mass number is already given to us. It's 15. Its nuclear charge never changes. It's the same number as its protons. All right, and that is it. That turned out probably to be a long video. Thanks for watching, guys. Hope that helps.